So we are doing the chain rule packet, and some of these I'm going to do with like just cover it up and bring it down. Other ones I am going to do with like the F and the G. You, of course, are welcome to do whichever way you want, and then just make sure that you're getting the right answer. All right? All right, so this is the outside, so I'm going to cover up the outside, and I'm going to say bring this down. So that's going to be y prime is 4, keeping the inside the same, 3, right? And then I just recopy, times the derivative of the inside, which is 3. And so that's 12, 3x minus 2 cubed. All right. The next one is derivative of the outside, keeping the inside the same. So that's 15 times the derivative of the inside. Let me go ahead and write that. Times the derivative of the inside, which is, now that's 0, so it's just negative 2x. Okay. The next one is the derivative of the outside, keeping the inside the same. So I'm going to bring that down. So that's, and I like to, with fractions, I like to write it up there so I can make sure I don't screw it up. Okay, so that's negative 1/3. And then times the derivative of the inside. Well, the derivative of the inside, and if you need to, maybe just write it on the side. So the derivative of that would just be 3. Okay. And so now this is an easily simplifiable and a negative exponent one. So I'm going to, those cross out. That looks like a negative there, but it's not. Okay, and then this is a negative exponent, so I'm going to move it down. And you could also write this as just 6 plus 3x to the 1/3. That's fine. Or you can also flip this and then change the sign of that, whichever way you want to do it. Okay? All right. Number 4 is, all right, well, first I'm going to prep this one. Okay. And now I'm going to do it. So bring it down. Okay. So derivative of the outside, keeping the inside the same. Times the derivative of the inside. Well, the inside is just x plus 3. So that derivative is just 1. Okay. All right. And then that's nothing. So I just do 1 over 2 square roots of x plus 3. You could also write it as a half times 1 over x plus 3 to the 1/2. Any of those things. Okay. All right. Number 5. Okay. So I'm going to do the prep work first. X squared minus 9 to the 1/3. Okay. And then I'm going to do the derivative of the outside, keeping the inside the same. Times the derivative of the inside. So that would be 2x. Okay. So then nothing's really easily simplifiable, so I just write 2x over 3 times x squared minus 9 to the 2/3. Okay. All right, now this one, you know, you might be tempted to do a quotient rule, okay? But there's really, you don't need to. This is just a constant multiple. So just write this as negative 2 and then x squared minus 3x minus 4 to the negative 2, okay? I mean, you're certainly welcome to do a quotient rule, and it will work out correctly. It's just, I mean, why do that? So when you can just do a polynomial rule with a chain rule, okay? All right, so the derivative of the outside, keeping the inside the same, times the derivative of the inside. And then nothing's really easily simplifiable here. So that's it. Okay. All right. Number 7 is a quotient rule if you want it to be, but really, look, watch this. Okay, so this is 9, right? Because square that one and square the bottom. And then now write this as 9 times 3 minus x to the negative 2. Way easier than the quotient rule, okay? All right, so now we're ready to do this. The derivative of the outside times the derivative of the inside. Now, I highly recommend, especially when x comes second, to write it over on the side just so you can see it. And then that's 0 minus, so that's just negative 1. So then this is 18 over 3 minus x cubed. All right, if you did the quotient rule, you're going to have to, like, simplify and see if you get the same thing as I did. You're going to have to, like, get common denominators, u prime v minus v prime u all over v squared. And then you're going to have to, like, factor out something and simplify to see if you get this. Okay? All right. Now this one, there's no trick to this one. You just have to do the quotient rule. So u is secant x. So u prime is secant x tangent x. Did you remember the derivative of secant? If not, you need to get it memorized, okay? All right, and then v is x plus 1 cubed. So v prime is 3 x plus 1. So this is a chain rule. Don't forget, just because you're in the product rule does not mean you can ignore the chain rule. So the derivative of the outside, keeping the inside the same, times the derivative of the inside, which is just 1. So I'm not going to write that. Okay. All right, so now I go u prime v minus v prime u all over v squared. So cubed squared. So let's think about that really quickly. If I do a cubed squared, what is that? That would be a to the 6, because you multiply these. So this is going to be a to the 6. Okay? All right, now simplify. So they all have a squared in them. So I'm going to take out these two and then 2 of those. So I just get 1 left and 2 of those. So I get 4. All right, and then that's it, really. I mean, you can do more if you want to pull out a secant or whatever, but there's no need to. Okay, and this is the meat of the problem again, but okay. And then so we get, and then I just like to write them in front so it doesn't look like it. X plus 1 secant x tangent x minus 3 secant x all over x plus 1 to the 4th. Okay. I like to make sure I label. Okay. All right. Number 9 is, I'm going to write this as 2x squared minus 5x plus 3 to the 1/3. Okay. And so then I go y prime is 1/3. 2x squared minus 5x plus 3 to the negative 2/3 times, all right, 2x squared minus 5x plus 3 is 4x minus 5. Okay, and then so that would be 4x minus 5 over 3, 2x squared minus 5x plus 3 to the 2/3. Okay. All right, this one is a product rule. Okay, so I'm going to do u and v. U prime is 3x squared, and v prime is 5 minus 3x cubed, time, and I always forget to do that, so really be careful. And you know, I do the bring down and then I just like write this and I forget to write my exponent, so be careful If I do it, you got a chance of doing it. Doesn't, you know, and also if I do it in the video and I forget to write it, then come ask me. Okay? All right. And then this is, what? So then, oh, that's the derivative of the outside, keeping the inside the same, times the derivative of the inside. So it would just be -3. Okay? And then, so now u prime v, so that is minus v prime u. So that's going to be negative. Okay, well, that's minus, and then this is -12, so it's going to be plus 12x cubed, 5 minus 3x cubed, all over. Now, remember, when you square a fourth, you're multiplying. So it's 5 minus 3x to the 8th. Okay? All right, and again, it's not super easily simplifiable. So, I mean, this is fine. I like to practice simplification because it's good for you. So, let's see, I take out 3 of these, and then I take out 3 of those, and I take out 3 of those, and that's what I get. Okay? So, this would be, all of that, well, I'm out of room, but that's okay. 3x squared times 5 minus 3x plus 12x cubed, all over 5 minus 3x to the 5th. Okay? All right, this one again is product rule. So u equals x, u prime equals 1. V equals 1 minus x squared to the 1/2. So v prime equals 1/2, 1 minus x squared to the -1/2 times -2x. Okay. I know I'm writing some of these kind of fast. I hope that you are trying it first and then playing it to see if you get the right answer. You can literally just fast forward and say like, yep, I got that one right. Okay. So you should not just be copying. That's a really bad idea. I know that you want to get done, but you should try and then check. Okay. All right. And then, so, u prime v plus v prime. Oh, you know what I did here? Back up. I did the product. I mean, I did the quotient rule. I have no idea why I was doing that. Make sure I didn't do that on any of the other ones. That's quotient, definitely. Didn't need that, didn't I? Okay, sorry about that. So you were probably very confused. Let me try that again. Sorry, I know it's like mid-problem. Let's try that again. U prime v is 3x squared times 5 minus 3x to the 4th plus v prime u, which is now -12. So that would just be minus 12, right? X cubed, 5 minus 3x cubed. And there is no b, so that's the answer. Sorry. Okay. All right, back to this one. So where was I? U prime v plus v prime u, and that's going to be a negative x right there. So I'm going to make that a minus right here. So minus, okay, and then x squared, and then 1 minus x squared to the -1/2. And it's not a quotient rule, so that's it, okay? And then this is y prime. So then y prime equals, and then this can just stay. Okay? All right, this one. So I'm going to call this u, and then this v. So u prime is, bring that down. There's going to cancel. A half times 2 is 1. So I just get an x. And then v prime is 1/2, 4 minus x squared to the -1/2 times negative, okay, oh, and let me write this out. So 4 minus x squared. So the derivative of that is just negative 2x. Okay. All right, so those cancel. And then it's just u prime v plus, but this is now going to be minus, and then that 2 already canceled, so you're still going to get a half. And then x cubed 4 minus x squared to the negative 1/2. This is all good. X cubed over 2, 4 minus x squared to the 1/2. Okay? You guys are going for a walk with Charlie?
Miss Melanie and Dakota here. I just wanted to let you know.
Oh, okay, well, I'm working. Okay. Okay, all right. Thank you. I'm making a video. All right.
We're not going yet because I haven't finished my history.
Oh, okay, we'll finish your homework first. Thank you. Love you. Sorry about that. Mom life. Okay, so the next one is u is x. And so u prime is 1. And then v is x squared plus 1 to the 1/2. So v prime is 1/2 x squared plus 1 to the negative 1/2 times derivative. So that was the derivative of the outside, keeping the inside the same, times the derivative of the inside. Okay, this cancels. Now this is a quotient rule. So u prime v would just be, so this is f prime of x, is x squared plus 1 to the 1/2 minus, and then x times x is x squared, and then this, and I'm just going to write this underneath. Okay, and that's the same as if I wrote it like out, and then my next step like I did here. I fixed it here. Same idea. For this one, I did the 2 steps where I wrote it times and then I moved it down. Well, with this one, I'm just going ahead and moving it down. Okay, I think we should get there and be comfortable with that. If not, take your time, write it, and then do the next step with writing that down below. Okay? All right. Now, this one is back to a chain rule with a quotient rule inside of it. See how it's the chain outside. There's an outer and an inner, and then inside there's a quotient. So that one I feel like is harder than this way. See, because this is just like a polynomial. So I like doing these with just like covered up, derivative of the outside, keeping the inside the same, times the derivative of the inside. I feel like I can handle that pretty well, but when I do it this way, I have a harder time. So I'm going to do that f and g thing that I did on the last video. Okay, so f of x is x squared because it's the outside. So f prime is 2x. Then g of x is the inside, which is t minus 3 over t squared plus 2. Now g prime of t. Okay, doesn't matter. I'm going to plug this into there, but I'm going to end with t, so I need to write that. Okay, and then this is, so now I got to do a quotient rule with this. Okay, so this is going to be t minus 3 is u, and u prime is 1. And then v is t squared plus 2, and v prime is 2t. All right, so then I get u prime v minus 2t times t minus 3 all over t squared plus 2 squared. Right? Okay, so then now, what is that? So that's negative 2t squared plus 6t. And I'm just like simplifying this top thingy so I can join them together. So I get negative t squared plus 6t plus 2 over t squared plus 2 squared. Okay, so now remember you take this one and plug it into there and then multiply it by that. So my answer, which you have a lot more room for this one, so you might want to do it on a scratch piece of paper or something. I mean, That's fun. Okay. So it is 2. So this is S prime of t. Is 2. Then this. Then this. Yep. And then there's nothing really easily simplifiable, so that's fine. It's a bit of a mess. Sorry about that. But there it is. Okay. All right. Number 15. Okay, so the derivative of e to the x is e to the x. Now, I want to be really clear about this. So d dx of e to the x is e to the x. Okay, but this right here is an input of e to the 2x. So that's a chain rule right there. And this is a chain rule. Okay, so I'm going to do the outside-inside stuff. So, all right, so f of x is sine of x. And g of x is e to the 2x. Okay, then f prime of x is cosine of x, and g prime of x. Okay, now this is a chain rule, so I'm going to write this. E to the 2x. This is an inside, okay? So I'm going to do the derivative of the outside, keeping the inside the same, okay? So, or you can do the f and g thing again, where f is e to the x, and g is 2x, okay? And then f prime of x is just e to the x. So you got to go all the way down until you get an e to the x. And then g prime of x is just 2. Now do this into this times this, right? Or do it this way. Derivative of the outside, keeping the inside the same, times the derivative of the inside, which is just 2. Okay? Or you can do this way. This goes in there, so you get e to the 2x times 2. Okay? Okay. Either way, you get 2e to the 2x. Okay? For g prime. Now, this goes into here, and then times this. So now I get y prime equals cosine of e to the 2x times 2e to the 2x. These do not multiply, so you don't add those or anything. This is really 2e to the 2x cosine e to the 2x, like that. Okay? You can leave it like this too. There's nothing easily simplifiable. It's just I want you to understand these do not multiply because this is the input of a function, and insides of functions cannot be touched. Okay? Without a special formula or something like that. All right, same idea with natural log. So the ln of x, d dx of ln of x is 1 over x. Okay? All right, so f of x here is tangent of x. And then g of x, or the inner one, is ln of x. Okay? So then f prime of x is, do you remember it? Derivative of tangent? Secant squared x. And then g prime of x is 1 over x. So here we go. So then y prime is secant squared of ln of x times 1 over x. Okay, and there's no really pretty way to write it. And these do not cancel again. These do not multiply or anything. And this is an input of in itself, okay? So you could write it as 1 over x secant squared ln of x. Okay? All right. Almost done. Last page. Okay. Derivative of cosecant. Oh, right. Okay. So the derivative, I got to remember it this way. So the derivative of secant is secant tangent. So the derivative of cosecant is negative cosecant cotangent. I seriously have to write it every time, just like I did there. Okay. All right. So this one. So the outer function is cosecant. Now this one I'm going to try doing it just derivative of the outside, keeping the inside the same, but be careful because this has got two inputs. See? So if you do the g of x thing back here, where I plugged, back here where I plugged e of x into cosine, if there were two things, it would have to go into all the x's for this. So cosine of x and sine of x or whatever it is. Okay? All right. So derivative of the outside, keeping the inside the same. See? Times the derivative of the inside, which would just be 2 theta, right? Okay, now do these. What was it? Theta squared. So then it's just negative 2 theta cosecant, not squared, cosecant theta squared, cotangent theta squared. Okay? All right, this one. The derivative, okay, so now let's prep this one. This is the cosine of x to the 1/2. And you should write it like that because this is, if you write it out here, you might get confused about what's outside and inside. This is inside, okay? All right, so let's see if we can do it. So the y prime, derivative of the outside, keeping the inside the same, times the derivative of the inside. And the inside the same would be root x. Okay, and don't be tempted. These are not canceling, okay, or anything. This is in front, in fact. So it's just negative 1/2 or 1 over root x. 1 over 2 root x, sine of root x. Okay? I don't know why I didn't write it just up top. It's prettier. Not that it matters. It's totally fine if you wrote it that way. It's not wrong. You would not get any points off. And I like to put parentheses because I really don't want to be tempted to cross those out. You cannot just cross those out and get like sen. That's not a thing. Okay? All right. This one. So pi throws everybody off. Okay? Always. The reason why it throws everybody off is because they think of it as a variable. It is not a variable. It's just a number. It's just 3.14. Okay? So it's just a number. Okay, so it's just a thing in front of it, like a 2x. The derivative of 2x would just be 2. The derivative of pi theta is just going to be pi. Okay? All right, so now let's write this. So this is 4 sine of pi theta squared. Okay? All right, so the derivative of the outside, keeping the inside the same, times the derivative of the inside. Now that I got to write somewhere. So the sine of pi theta. Okay. So keeping the inside the same. Let me write that. Ooh, see, I almost forgot it. No, I didn't, because you take off 1 and you get 1. Okay. Derivative of the outside, keeping the inside the same. That's a little confusing. It looks like it's multiplied. Let me move that down. Times the derivative of the inside. Okay, well, just like when you did sine of 2 theta, I told you it's best if you just remember this thing and goes in front and then the derivative. But if not, derivative of the outside, so the derivative of sine is cosine, right? Keeping the inside the same, times the derivative of the inside. The derivative of pi theta is just pi. So now I get pi cosine pi theta. Okay? And there's nothing really easily to simplify or anything, so I'm just going to leave it. Okay. This one, last one. All right. So I think I'm going to write the f and g one for this one. So f of x is sine of x. G of x is cosine of 3x squared. Okay. Now, f prime of x is cosine of x. G prime of x is the derivative of the outside, keeping the inside the same, times the derivative of the inside, which would be 6x. Okay, so now I take this and shove it in there. And that is not going to give you cosine squared. Cosine of cosine is just cosine of cosine. It's just ugly. Okay, times this. Okay, so y prime equals cosine of 3x squared times negative 6x sine of 3x squared. Okay? And if you want to make it pretty, you can put this in the front or whatever. So it would be negative 6x cosine of 3x squared sine of 3x squared. Okay? But this one was totally fine. You don't have to go any farther with that one. Okay? All right, that is it.